Hello everyone, today let's solve the problem number 50, power of x comma n here. So what the question states here, we need to implement a function my power x comma n. You can clearly see here my power x comma n, which calculates x that is raised to the power n, x that is raised to the power n, nothing but here in this case 2 to the power of 10, nothing but 1024 here, right? So that's what we need to implement here. So let's consider the example one here. Let's come to the example one here. Just give me a second here. Yeah, you can clearly see here. So this will be 2 to the power of x to the power of n is nothing but 2 to the power of 10. 2 to the power of 10 is nothing but 1024. So that's what they have given here. Right. So the second example here, 2.1, they have considered here floating point integer. So n, this to the power of 3, it will give us the output. We have to get the output 9.26100. Right. So same goes with example 3 as well here. 2.00000, nothing but to the power of minus 2 as 0.25 triple zero. Here they have explained clearly as well. 2 to the power of minus 2 is nothing but 1 by 2 square. Here 1 by 4 is 0.25. So that's the reason we have got the positive, this one here, positive floating point integer right here. So this is fine. Next what we will do, let's discuss the approach. I hope the question is completely clear what we need to do here. So let's discuss the approach first, followed by edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially what we'll do, let's discuss the approach first, right? So let's discuss the approach first. When I say let's discuss the approach first, so just give me a second here. So let's discuss the approach. The first thing that we need to keep in mind here is we will be going with the fast exponentiation approach here. Simple math right here. We'll be going with the simple math here. Simple math calculation or fast exponentiation, right? So here in this case, the same example that I've considered here. The first example that they've given in the question, the same example that I've considered here. X, they have given this one. N, so 2 to the power of 10. The answer that we need to get here is 1024.50 here in this case. So let's see the approach, or let's discuss the approach step by step, right? So here in this case, first what we will do, we will break down the power using recursion. We have to articulate our thought process has to be in the form of articulating that one in the form of code, right? So that should be our thought process mainly. Here 2 to the power of 10, I have considered 2 to the power of 5 into 2 to the power of 5. So we are breaking down the power using recursion here, right? So this will be 2 to the power of 5 into 2 to the power of 5. So since 10 is even here, you can clearly see here, 10 is obviously even here, right? So since 10 is even here, we are computing 2 to the power of 5 and we will square it. So we compute 2 to the power of 5 and we will square it, right? So that's what we will do here. So let's come to the second step here. In this case, we have 2 to the power of 5. 2 to the power of 5 into 2 to the power of 5 we have, right? So first, for computing the 2 to the power of 5, we will break down this one into 2 square into 2 square into 2 here. So 5 is odd here. You can clearly see 5 is odd here. So 2 square into 2 square into 2 we will consider. So since 5 is odd, we compute 2 square, square it and multiply by 2 finally. So that's what we will do. So the third step, we have 2 square here. So let's discuss step by step here. So this one 2 square we have here. 2 square equals 2 to the power of 1 into 2 to the power of 1. We can write in this way, right? 2 to the power of 1 into 2 to the power of 1, because we have 2 square which is even. 2 is even here. Since 2 is even here, we will compute 2 to the power of 1 and finally we will square it, right? So let's come to the fourth step here, 2 to the power of 1, nothing but the base case here. So 2 to the power of 1 here is 2. Since 1 is odd here, we will return x equals 2 in this case. 2 to the power of 1 equals 2. Since 1 is odd here, we will return x equals 2 in this case. So let's multiply results back up. So here 2 square, 2 into 2 is nothing but 4. We know this, 4. 2 to the power of 5, we got 4 into 4 into 2, nothing but 32 in this case. And 2 to the power of 10 will be 32 into 32 here in this case. 32 into 32 will be obviously 1024. You can just check this one. 32 into 32, this will be 1024. So overall, this one answer will be 1024. We'll be considering this one, right? So we got the 1024. 24 here, right? So the answer that we got and the answer that they have given in the output is same. This is equivalent to the output that they have given for the example one in the question. So both the solution match here, whatever the approach that we went with, and whatever the solution they have given here, output. So both match here. So our approach works absolutely correct in this case, right? So let's move on with the this one step by step explanation quickly. So if n is even, we will recursively compute x to the power of n by 2 and square it. We saw this one. If n is odd, we compute x to the power of n minus 1, then multiply by x to adjust for the first exponent. This one, just keep this in mind. This is very important step. So mainly this one. If n is odd, we will compute x to the power of n minus 1 and multiply by x to adjust for the first exponent. So this one, while writing the code, it will be handy. So just keep this in mind. If n is negative, so if n is odd we saw, if n is even we saw, if n is negative, then what we will do? We will convert x to the power of n into 1 by x to the power of minus n. We saw this one in the example already, right? The third example, I think, right? So I hope this is completely clear. If n is negative, we will convert x to the power of n into 1 by x to the power of minus n. So we considered for when n is even, when n is odd, and when n is negative. So we have already solved this one by making use of first example, by considering the first example, sorry, right? So I hope the approach is completely clear. So the same thought process, we have to articulate that one in the form of code after discussing the edge cases, right? So let's discuss the edge cases quickly here. So the first edge case here is negative exponent. So here we have 2.0, this one 5 zeros, and n is minus 2. So here 2 to the power of minus 2, as per the rule previously we have discussed, this we will be considering 1 by 2 square here in this case. This becomes 1 by 4, nothing but 0.25 in this case. So here this one, this case, right? If n is negative, then we will convert x to the power of n into 1 by x to the power of minus n, right? So let's come to the second step here. Base as 0, x equals 0.5 zeros we have given here, n equals 5 we have given here. So in this case, what we will do, output will be 0.00000 itself, because 0 to the power of anything, it will be 0 itself. 0 to the power of n is always 0. This edge case, just keep this in mind. So this is very important. This edge case, base as 0. So the next edge case here is exponent as 0. So here x to the power of n, anything to the power of 0 is always 1. If you remember, any number raised to 0 is always 1. We have learned this one in school itself, right? So anything to the power of 0 is 1. We know this one, right? So here in this case, 10 to the power of 0, any number that is raised to 0 is 1. 10 to the power of 0 is 1 here. Let's move on with the fourth edge case here. Negative base with odd bar even power. In this case, minus 2 to the power of 3. Right? Minus 2 to the power of 3. This will be minus 8.50. We need to get here. This is fine. So since n is odd, the result is negative. N is odd here in this case. So the result will be quite obviously negative. If the n is even, then output would have been positive, right? So in this case, x minus 2 we have considered, n we have 4. So output will be 2 to the power of 4, nothing but 16 in this case, 16, 4, 5, this one. So why we are considering this one 16 here, positive 16, because n we have even here in this case, n odd, negative, n even, positive. So these are the 4 edge cases that we need to consider. The first edge case was for negative exponent, the second edge case was for base as 0, the third edge case was for exponent as 0, the fourth edge case was for this one, negative base with odd or even power, right? I hope this is completely clear, right? Next, what we will do, let's start writing the code. I hope the approach and edge cases are completely clear, right? Now let's start writing. Here the first we'll go with 2 edge cases, nothing but we have already discussed this one. 0 to the power of n is always 0, and x to the power of 0 is always anything raised to 0, that is always 1. Let's articulate that one in the form of code. Here we have x and n as parameters, right? So let's articulate this one in the form of case, this one code. So if x equals 0, nothing but here 0 to the power of n. So in this case, we will return 0, right? So I hope this is clear. Next edge case is x to the power of 0 equals 1. So I can write in this way. One more if condition here. If n equals 0, then what we will do? We will return 1 in this case. So I hope this is clear. Next thing is we will take the absolute value of n. So when I say we will take the absolute value of n, here this one is abs n I will consider here. This one will be math.abs absolute. I'm considering we have the math.abs, right? So function. So this one I'll consider math.absolute of n. So this is fine. So we are just taking the absolute value of n. Next, what we will do, we will recursively calculate the half power. So this one will be let half equals my power of x comma. So this one will be a double tilde operator of absn. We have this one. I'm considering this variable absn by 2 here. This is fine. So we are recursively calculating the half power. So we saw that one during the approach while we considered the first example, right? So we went step by step. So this is what we are articulating same thing that in the form of code here. So we will square the half power and multiply by x if n is odd, right? If n is odd, then we will square the half power and multiply by x. So how can I write that one? Let result equals half into half into absolute this one. I'll just consider here in this case absolute n module 2 this one x this one will be 1. This is fine. So this one y I have given 5 here. This one has to be modulo. So this is 5 module 2. So this one if it is then x we have to, if it is not, then we are going with 1. This is fine. So the final step is if n is negative, then we have to take the reciprocal. We have discussed that as well. So if n is negative power, right? If power is negative or n is negative, then we have to go or we have to take the reciprocal. So just I'll come here. Let me return in this case n greater than 0. This one result, then if not, then 1 by result, right? This is fine. So in this case this is it for the code. So let me hit the run button. I hope this works. Let's see. So you can clearly see here the sample test cases are getting passed here. Let me quickly hit the submit button. So I hope this works. Let's see. So you can clearly see here all the test cases are getting passed here. So the code works absolutely fine in this case. The code works absolutely correct in this case, right? So what will be the time complexity and the space complexity here? So the approach that we went with here is exponentiation by squaring. We know this one, or fast exponentiation we can call it, right? So the overall time complexity would be here big O of logarithmic n. So this is one of the advantage, right? So here it is not big O of n, here it is big O of logarithmic n. And what would be the space complexity here? Space complexity is also big O of log n because we are making use of the recursion, right? So we are going with the recursion here. So overall space complexity would be big O of logarithmic n as well here due to the recursion. So overall time complexity would be big O of logarithmic n, and the space complexity would be big O of log n as well due to the recursion. So I hope this is completely clear. I hope the code or the solution that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.